Hey folks, welcome. Latest edition of Ask the Experts. I'm Mark Brown, and I'm here with a bunch of our colleagues here. We're going to talk about building intelligent apps with Azure Cosmos DB. Let's just have everybody, we'll just go around the horn here and introduce ourselves. Gal, you're at my top left or top right. I'm not which way. It's this direction here. Why don't you say and introduce yourself there?
Hey everyone, I'm Gal. I'm a PM on the team.
Hey, all right. So we're going Brady Bunch style down here. James, why don't you say hi?
Hi everyone, my name is James. I'm also a PM on Azure Cosmos DB.
Okay, and then Jasmine over this direction.
Hi everybody, I am the odd one out here. I'm a cloud advocate, but I'm super happy to be here today with everybody.
Oh, that's cool. Ray, good to see everybody today. Let's get into it. If we can get our deck up in here. I'm not quite sure how to. There we go. Welcome to the session. Just to give you, if you're not familiar with Cosmos DB, what is Cosmos DB? Because sometimes there's some confusion. Cosmos DB is not just a single database service. It's actually a suite of databases all within Azure. More specifically, it's a suite of distributed databases, both NoSQL as well as relational database as well with Postgres. Today, we're going to talk about our two main databases that are really designed for building intelligent or AI-enabled applications. We have Azure Cosmos DB for NoSQL, and then we also have our Azure Cosmos DB for MongoDB vCore. On the left side, the RU-based NoSQL is really designed for massive scale and very high elasticity. You get real-time auto scale, you get very high nines for availability, extreme low latency. It's really designed to go from 0 to millions of users and do it in a very easy fashion. You don't have to do a lot of management or oversight or anything in that. It just scales out as you need. On the other side there, we have our Azure Cosmos DB for MongoDB vCore. This is intended as more of a vCore-based model for designing and building Mongo-compatible applications. Also going to get very good high availability in there, burstable SKUs, real-time data and real-time transactions, high compatibility for MongoDB, and also, most importantly, and we'll talk about this a lot today, support for HNSW for your vector search within the database. Okay, so everybody's talking about AI. It's just been crazy for the last, 14, 15 months since ChatGPT kind of hit the world. And everybody is talking about AI and what you can do with it within your applications. And there are a lot of customers, Microsoft customers, and just people all over the world that are looking at their existing portfolios or maybe looking at building new applications and wondering, how can I leverage this generative AI set of technologies within my applications? And here's kind of just a choosing of different applications and services. Things like transaction processing. This is something we see a lot within our Cosmos for NoSQL because a lot of these transaction processing systems for banks and others and credit cards require massive volume and massive scale. They're looking at leveraging generative AI and building these solutions. Other things like product information and discovery. This is another very big use case for Cosmos is in retail. And our customers are looking at how can they leverage generative AI to help find products and services that our customers can then go and buy. Gal, I know there's also some other services and products that you're familiar with. You want to share on those?
Yeah, you'll hear more about this later, but there's actually a company developing a connected car, which will allow you to talk to the car, something totally new that was never done before. And we have an example about that later on in the presentation.
Yeah, that's great. And then James, definitely on the Copilots, we've been doing work on, everybody at Microsoft's building a Copilot for something, right? We've also been on that bandwagon too, and also building Copilots, correct?
Yeah, absolutely. So we recently launched our Copilot for Cosmos DB that allows you to generate NoSQL queries just based on your natural language questions about your data. But we're seeing, thousands and thousands of customers really interested in building their own Copilots, and an integral part of that is leveraging their data stored in a database like Cosmos DB and bringing it to their large language models to sort of contextualize them for their scenarios. So lots of great stuff that we can do here.
Yeah, absolutely. James, you want to talk a little bit more? I mean, let's kind of decompose these scenarios around how you use or where you would use Cosmos DB with building generative AI scenarios.
Yeah, great. Yeah, so there's a couple of areas that we're seeing that are extremely popular today with our customers, and interest just keeps growing. So the first is around vector database scenario, right? So I can create what are known as embeddings from my data. They're vectors, right? They're just arrays of numbers, and these vectors have some semantic representation or semantic information related to my data. So I can use, for example, one of the Azure OpenAI models to create embeddings for my text data. And for Cosmos DB, I can store that vector embedding data just as another property in every document right alongside my original data. And I'm able to conduct vector similarity search to find similar items in my database. So vector database, vector search is one of the scenarios that we're seeing a lot of use cases. Now, building on top of that, there's something called retrieval augmented generation, which I'm sure most of our viewers have heard a lot about, right? So the idea behind this is I have data in my database, and I want to choose the right data to bring to my large language model in order to ground it and inform the model about my scenario, right? And so identifying what the right data is for, say, a customer's question that's posed to a chatbot is really important. And you can use vector search and our vector database capabilities to do just that. Another use case that's really popular, we have thousands of customers doing this today, is chat history, right? So logging the user prompts or user questions and the responses generated by your large language model, and storing this for later analysis, right? And you'll be able to get deeper insight into what your users are asking for. You can also leverage it to improve your experiences with your large language model. So really a lot of interest there. And Cosmos DB is a great product to use for the chat history scenario. Now, building on top of all of these is something called semantic caching, where the idea is you log these histories from your large language model, similar to what you do in chat history. And then if you have a user question posed to the large language model, instead of having to call the large language model API, which can be expensive and it can be costly, and it can also have a latency associated with it. Instead, you can just leverage historical responses that have been generated. And we'll talk a little bit more about that later on. But that sort of builds on the chat history and vector database scenarios. So again, lots of different use cases for databases and generative AI models. But these are like the four that we've seen a lot of interest in lately, and we'll talk about more today.
Yeah, that's cool. Thanks. That really, I think, helps ground kind of all the different scenarios and just how you could use Cosmos DB in building these types of generative AI applications. I wanted to kind of double click into our MongoDB for vCore. So we just GA'd this back at November at Ignite, and super exciting. And we're getting a ton of customers that are coming and checking it out and going and building new generative AI applications using it. In fact, we'll talk about a couple of these customers. And what's great about our MongoDB for vCore for Azure Cosmos DB is you get this high level of compatibility. So customers that are using MongoDB today can go and get very high compat. And also just because it's a vCore model and not an RU model, it's going to have a lot more of a familiar behavior, if you will. And then, of course, you tack on things like, because it's a first-party service, it's going to have a lot of great integrations into the rest of Azure. This is really super important. I mean, compatibility with Mongo is important, but if you're building in Azure, you want it to be able to work with these other services that you're hosting and using in Azure, whether it be web apps or ACA or Azure AD or any of these things. It's super important that you have that glue that can pull these things together. I wanted to kind of go into some detail as to just more about what we GA'd here. I mean, of course, we have that familiar syntax integrated into Azure. And then, of course, the built-in vector indexing. So we started with the IVF-based vector indexing last year. And then we announced the preview for HNSW back at Ignite. And that's just really taken off. And we'll talk more and more. I want to keep jumping on the gun on all the stuff we're doing around this. But there's just a lot of great technology and great stuff that we're just building into this thing. And then, of course, we have a free tier for this as well, free forever. So just go and create an account, mark it as free tier, and then go and start building and prototyping your applications within or using Azure Cosmos DB for MongoDB vCore. Let's talk a little bit about, hey, Gal, what's up? About a customer that we had at Ignite. And Gal, you're just in time. You want to talk about KPMG and what we did when we were on stage last November?
Yes, sorry about the connection issues. KPMG built all of their generative AI applications on top of MongoDB vCore. That means that all of their knowledge base is in this chat application where the data is actually backed by MongoDB vCore. And at Ignite, when we GA, they actually presented the next slide where they talked about their accuracy going way up from MongoDB vCore, as well as their performance, latency, and accessibility around knowledge base.
That's great. So now I know they started with a small set of users within KPMG. That's actually grown quite a bit now, hasn't it? Since they've gone and announced and made this all public, right?
Yeah, all around the world. Very, very exciting.
Yeah, that's amazing. So they're supporting thousands of their people internally with this huge knowledge base, all natural language interface. I mean, this is fantastic. The data that they've got is now fully accessible by their entire organization. And so they can go and ask questions about nearly anything that they've got in terms of knowledge at KPMG. So that's a really super exciting use case. You touched on this earlier, Gal. I'm really excited about this one. This is also brand new. So TomTom, those guys were famous for building GPS systems back in like the 90s when microfiche was kind of a thing, maybe still, or maybe not. But long time ago, they have really expanded their business, and now they're building a complete car experience, all voice activated, this digital cockpit, and using generative AI. And they can do things like turning on entertainment or infotainment, if you will, doing location, vehicle commands, and it's all voice activated within there. So you're essentially just talking to these large language models and then asking it to complete these commands within here. And they're using a great set of services within Azure, right? Like this integration with all these first-party services within Azure really, really matters, which is why choosing a first-party database for all this stuff can really make a big difference. And so using Azure Cosmos DB on the back end, of course, Azure OpenAI service, all the COG services, the finished services for language understanding, so text-to-speech, location services for Bing, and then, of course, hosting an Azure Kubernetes service to bring it all to their customers and provide that amount of scale and availability they're going to need for their customers in there. So great amount of integration that is happening across all of the services that are within there. And speaking of integration, Jasmine, we've done a lot of integration around Azure Cosmos DB from MongoDB vCore. You want to talk a little bit about what we've invested in there?
Sure. Yeah. So, many of you out there building all these amazing apps probably have a lot of services and a lot of other things that you do in your applications other than just accessing and using your LLM. So so now you can actually be able to use these integrations like Semantic Kernel, LlamaIndex, Langchain, as well as Azure OpenAI in Azure Cosmos DB, vCore, and use your LLM. So we're going to talk about a specific version or a specific use case here in the next slide, focused on retrieval augmented generation. Now, this essentially is a pretty popular common pattern that we've seen in a lot of presentations and demos, and we're going to walk through this demo here or this architecture diagram here. So, when you have a set of data, and this data is essentially a set of facts, right? You want your users or your end users to be able to generate or get some information from this data. How do we organize it in a way or present it in a way that the users can be able to get the answers that they need? Well, with RAG, what we'll call it from now on, in this architecture here, we have our database here, or our Azure Cosmos DB data store here. And in this diagram here, we're using an Azure function. And this essentially allows us to create an endpoint that will vectorize our user queries, as well as any particular data that might be stored in Azure Cosmos DB and also stored in our database in our collection. And we actually use Azure OpenAI to vectorize these queries. And then at that point, the users can go ahead and interact with this data through either an application or an additional service. And one of the benefits here is you're probably asking, why wouldn't I just use a separate database for this? Well, this will add a little bit more complexity to this diagram if you did that, right? Imagine having a second database, another operation, a lot more time to get your data. Why can't you just be able to use it all in one place? So this is essentially one of the benefits of just being able to access have your users be a little bit closer to your data in terms of leveraging LLMs to be able to help them out there. So now we're going to actually get into a very quick demo of this. So I'm going to swap here to my notebook here, and James actually created this amazing demo in this notebook with applying this RAG pattern. And what I've gone in here and done is actually imported the Langchain library to be able to do the same exact demo here with Langchain. So again, speaking to those integrations that that are in Cosmos DB now. So starting here from just going ahead and setting up the connection. So you'll notice in the notebook when you try it out for yourself that there are some additional steps and setup and things that you can do. But I'm just going to go ahead and hop right into setting up our connection. Just here we're using the PyMongo library to do that. My collection is already created, and that's all already set up. And just some code here to drop your index or database should you need to. But here's where it gets interesting. So notice that I have this Azure Cosmos DB vector search class. This is actually from the Langchain library, the Langchain OpenAI library. And here what I'm doing is going ahead and creating my vector search object and also creating my vector store object from my connection string. So the way this works is that once you have your data loaded into your in your collection and your collection's all set, you can actually just go ahead and connect to Cosmos DB just by your connection string, and then and of course access your namespace as well as access your embeddings object in Azure OpenAI or OpenAI as well. This is also being accessed through the Langchain library. So one of the default ways to, in terms of vector indexing is IVF. And in fact, if you don't actually use the create, when you use the create index function here, this is actually the default setting. There's also HNSW, which stands for, I believe it is high. Can somebody help me out here with
this hierarchical navigable small world? Just like everything in generative AI, it just rolls right off the tongue. Just like retrieval augmented generation. Like, wow, why didn't I think of that?
Yes, thank you. It's right here, right in front of my face. And so if you're trying it out here, you can learn a little bit more about it too. And I actually have this compressed in here because the way this works is that you can either only create a IVF vector or HNSW, so a vector. So you cannot, or index. So you cannot do these at the same exact time. So you have to choose one. In addition to this, HNSW is actually in preview. And in this notebook, you have some information how you can access this particular preview feature if that is of interest to you. So after I upload my information to the collection and I can test here and double check and make sure everything is there, here is the meat of my query here. So this actually was what I was doing in the original, or what James had actually written in the original Azure OpenAI MongoDB core tutorial, but I actually can skip over that and hop right in here into this new cell that I created here to do the same exact thing. So
that looks a lot simpler, by the way.
Yeah, right. A lot less verbose.
Yeah.
the thing here is that you can actually make it as verbose as you want to. One thing that I didn't point out here in the index here, these are there's additional arguments that I could actually add in here that will get filled, that are just filled in by default. But here I'm just going ahead and adding some just additional arguments here. But just moving on here, the way that we're doing this similarity search is just with this function right here. So I'm actually going to go ahead and click on this. And before I do, I actually already ran this cell, but we're going to change this up and change this to what are the services for DevOps. And let's see what we get. So this collection is a set of just information about the different Azure services. And if you look at the file, there's a test file in this repository that has all this information, the title, the content, as well as the vector values as well. And as we can see, it has returned some services that might be useful for me if I was thinking about strategizing or creating a DevOps strategy around Azure. Now there are some more features in this notebook where you can actually chat with this data, and I'm not going to get into in the interest of time, but I highly recommend you check it out and go to the repository if you are interested. So let's move on to the next thing.
Yeah, that's very cool. These integrations are so important. Like, everybody seems to be wanting to use these AI SDKs, if you will, whether it's Langchain or Semantic Kernel. I think LlamaIndex is another as well. I think they provide a little bit of abstraction at first, but I think in the end, I think it provides a much simpler, cleaner way of being able to not just build, but kind of assemble these applications. Let's go back to slides, and then I want to talk a little bit more about chat history. So, James, why do we care about things like chat history? Like, that's it's kind of a part of this whole process of building these applications, right?
Yeah, absolutely. I mean, there's multiple different use cases where chat history can be helpful, right? So first is around memory, right? Providing short-term or long-term memory for your large language model. So if I'm building a chatbot, maybe I want it to remember what a particular user talked about in the previous session or yesterday or a week ago, right? I may want to perform some offline analysis to better understand what are my users asking about. I can, go through the data and actually I can use the large language model to help me summarize this, but I can actually use this to help me do meta prompt engineering or fine tuning of my LLM. And we talked about semantic caching, right? So leveraging previously asked questions or previously generated responses from my large language model to reduce cost and latency by reducing calls to the large language model, right? Creating an embedding is significantly cheaper than making a call to a large language model API. And then also importantly is like auditing, right? Like you'll want to maintain a trail of all of the interactions for your large language model. This is really important, I believe, and Microsoft believes, for every single application, but it's particularly useful for, heavily regulated industries like in finance or in healthcare.
That's true. In fact, anybody that's ever called any kind of customer service has always heard this recording here. Like, your call may be recorded for quality assurance. Like, that's just something that a lot of companies, service companies, and their customer service divisions just do. And you're talking not to a computer, but you're talking to a person. Well, why did they do this? Well, one, you need to be able to audit these things and know what was said by your agents to your customers. And not just for an audit point of view or maybe legal or whatever, but also so they can help improve the information that these agents are sharing. Well, if you're doing it with a human, it's even more important if it's a if it's a computer or a large language model that's talking to your customers. I mean, maybe they're making recommendations or saying, hey, you should go do something or buy something or whatever. They're not infallible, right? And kind of the whole point is you want to make sure that you've got an audit trail of this information that is shared and these interactions that happen with customers. And then as well, like James was saying, there's work you can do on top of that data, like analyzing those interactions, analyzing what's shared, analyzing what's asked. You can make the accuracy better, the experience better, maybe improve the cost or the performance of these interactions better as well. So all these things matter in terms of chat history, and it really should be a part of the development and the experience of building these RAG pattern applications. And just to point out, like building chat applications is something that Cosmos has been doing since way before generative AI was ever a thing. We have companies that have built mobile applications and provide their customer service agents. Vips is one here. There's lots of other companies that for years have been using Cosmos to go and do this because it's just well suited to building these types of applications. In fact, if you ever worked at home for the last 4 years after the advent of COVID and used Teams, I don't know if you know, but Cosmos was the database, or is the database behind the chat feature within Teams. So you may have been using Cosmos and not even know about it. And just to give you kind of an example of just the amount of scale and elasticity here, I mean, Teams before COVID was already a massive global service. And then COVID happened and things just went crazy. I mean, and even today, even after COVID and people kind of started going back to work, you still have things like Teams that are generating petabytes of data a day through text and trillions of transactions that are happening every single day through things like Teams. So just to kind of give you an example of why people use Cosmos to go and build these chat applications and why you should, is super important to understand that the capability of the service is there and why people use it. Not to mention, it's also a JSON database. These conversations can tend to be somewhat unstructured. Having that flexibility to be able to define basically any schema and then evolve it is certainly important. And just to put a point on this, you may have heard of these guys. So Azure or OpenAI, when they released ChatGPT, they used Cosmos as the backend database for all of the chat interactions. So when you go to OpenAI and use their ChatGPT application, and you have a conversation with it, and then it goes and summarizes that, it's storing that using Cosmos DB. So it uses it to have that conversational memory and that context so you can have a conversation with them. It's using it so that you have a record of all of those past interactions with ChatGPT, so you can go back and click on those things and see that conversation that's happening or has happened, and then pick it right back up again. So I wanted to show you kind of a little demo of what happens if you have that conversational memory there that you can feed a large language model like ChatGPT, and then what happens if you don't have it there. So what I want to do is I want to show you a little demo. So if we can go over to my other screen here. Yeah, so I have a little sample app I've built, just Cosmos DB/ChatGPT, and we'll share the link later. It was in a slide earlier, but this is up on GitHub. You can really quickly and easily just do a one-click deploy. Here's kind of a look at the user face in here, and I'll go past a whole bunch of text here. But you can deploy this right into your Azure subscription. The first button here will deploy everything Cosmos, an Azure web app, and Azure OpenAI. Or if you've got an existing Azure OpenAI account, you can just use that second one and then feed all that information in there. And after a few minutes, this is what you get. Is you get a really simple little chat interface on the left-hand side here. I'm going to create a new chat. So let me just show you what happens when you have conversational memory and conversational context built in as part of these RAG pattern. Well, this isn't RAG pattern specifically, but built in as part of these generative AI applications. So I'm going to ask it, what is the largest lake in North America, right? And this should be Lake Superior, right? So that is the very largest lake in terms of volume size in North America. Now I'm going to ask it a follow-up question. So I'm going to say, what is the second, right? So I provided no additional context, no nothing. And what it's going to say is it's Lake Huron. And the reason it's able to answer that accurately, because my prompt did not have enough information in there, is it looked at the history of that chat. So this application sends back, at least here, it sends back a bunch of the conversational history, and that's fed into the large language model so that it has some context for, okay, I've already answered it. It's Lake Huron. What he's asking about is what's the second largest lake in North America. Well, let's see what happens if I don't do that. So I'm going to show, where is my, so here's the code for my little web app here, and I'll show you this here. And I don't want to spend too much time, but what happens here when you push enter is you call this function get chat completion async. And what it's doing is it's going to save the prompt that comes in. But the first thing it does is it grabs a conversation history that comes in here, right? So I'm using a session ID. That's essentially the conversation that's happening. And then it's taking that and adding the prompt to it. And then it's going to send all of that to, well, normally it would say this, it would be this, it would send the whole conversation to Azure OpenAI service. And then OpenAI service would generate that completion and then send that back. But what I'm going to do here is I'm just going to send the prompt text, right? So I'm not going to get any conversation history in here. And let's see what happens. So I've got a little instance of this thing running right here. And this is here running locally. So I'm going to start a new conversation. Let's ask it this question. So what is the largest lake in North? I can't type it today. America. And there it is. Largest lake is Lake Superior, right? That's the correct answer. What is the second? Right? Not passing in conversational history. And there you go. So it comes back with something that it can only come back with because it doesn't have the context in here. And it's guessing what is the second of what, right? Second of a second of a minute, second of a pi, whatever. So this is what you get if you do not provide that context. Is you're going to get largely nonsense. It may come back and say, I have no idea what you're talking about, but it's going to try its best to generate some sort of answer for you in there. So that's the important why. Just one reason that you want to store that conversational history is that it actually makes sense and is necessary to have that conversation with users. Okay, let's go back to slides here and we'll keep on trucking with our presentation. Okay, so James, we talked about Mongo vCore and all the integrations in there, and customers are using Cosmos NoSQL and MongoDB vCore, but definitely with Cosmos DB NoSQL to do all the chat history in there. Can you talk about kind of what's coming down the road with the Cosmos DB for NoSQL?
Yeah, absolutely. So today, if you want to do vector search with Cosmos DB NoSQL, you have to use another service on top of it, like Azure AI Search. But what we're announcing at the Build conference this May is built-in vector search and vector indexing in Azure Cosmos DB NoSQL. So this will allow you to conduct vector similarity searches through our query syntax. And it's going to be powered by DiskANN, which is a highly performant and scalable vector indexing algorithm that was developed at Microsoft by Microsoft researchers. You'll be able to store your data and your vectors together in one document. And again, your vectors will just be another property of your document. We'll have easy to use NoSQL query syntax, so you can execute it from your existing queries across all of our SDKs. And like I mentioned, we're launching in preview at our Build conference. I think it's the third week of May, this 2024. And we're actually giving a sneak preview of this at the Fabric conference that's happening at the end of this month in Las Vegas. So come on over to the Fabric conference and you can see us giving a sneak peek of how this is going to work. And then, of course, as we do with Cosmos DB for MongoDB vCore, we pay a lot of attention to our integrations with Semantic Kernel, Langchain, LlamaIndex, etc. And we're planning on having those integrations in place at launch as well. And again, this will be available in preview at Microsoft Build in this May.
That's awesome. I'm really excited, James. You made a little bit of news here about FabricConf and getting a little sneak peek here. So I am very excited, and we'll see you there at Fabric Conference, and hope to see all you all there too. Come join us in Vegas here. It's just 3 weeks away, actually, I guess, right? A little more than 3 weeks. So come check us out. Hey, I think that's mostly it. We have a little bit of time for questions. One more thing, we've built a whole bunch of solution accelerators. One in particular I want you to check out, and this uses the same kind of architecture that you saw with folks like TomTom. And others that are building on Cosmos NoSQL is our solution accelerators that we've built. And this is available on GitHub here. It shows you how to build these RAG pattern applications using chat history, using Cosmos DB, using AKS to host, using Azure AI Search is also doing the vector indexing and search in there as well. Built using Semantic Kernel in there as well. So you get all of the big pieces and shows how they go together. You can go and clone this thing, customize it, and then go and deploy it and get it all stood up. It's really there to kind of show you how these things come together, how to put all the big pieces together into one solution in an easy to customize fashion. So go and check that out. It's ready for you now, and we're constantly keeping that up to date with new versions of Semantic Kernel and all the other SDKs that are in there, as well as Cosmos. So I think we may have a question or two from the audience. I'm going to put up a slide here with a bunch of cool links. Feel free to take a screen cap of this or just write them down real fast if you want. But yeah, if we want to show a question here, let's take a question from our audience. From Bill Reynolds, we're building Quarbine, a native Cosmos DB analytic and reporting suite. We're integrating Azure AI and OpenAI embeddings and completions. The output from Codeless RAG is amazing. Thanks for the demos. Well, thank you, Bill. Appreciate that. That's great.
We also had another question come in. Let me see if I can find it here. Yes, is Cosmos DB the same as Pinecone?
Oh, that's a good question. James, I'm going to let you take that one.
Yeah, it's a great question, right? So Pinecone is a dedicated vector database that can store some additional information. Cosmos DB is a highly scalable, distributed general database, right? So it's really powerful for high transactional workloads, features high availability, high SLAs, low latencies, like Mark said. Pinecone is a dedicated vector database. It tends to perform well and have optimizations around vector operations. So if you want to store all your data to one place and you want to leverage the vector search capabilities that we're developing in Cosmos DB, you can use a single source like Cosmos DB. I also saw another question here from Bill that I just want to follow up on real quickly for the preview access for NoSQL vector search. Yeah, so how exactly you access it has yet to be determined. It will likely be a preview feature that you can enable for all the Cosmos DB resources in your subscription.
Got it. Oh, wait, I saw a question quickly and then it went away. Can you bring that question back from Bill? It should be minor syntax change for what we've already built using Mongo's vector syntax. Exciting stuff. So, yep. Any other questions? I just want to point out, so some of the great links up here. We have an article on Docs on all the vector database options. Also links that takes you out the sample, so that's good fan out there. You can start there. The RAG pattern samples that Jasmine showed earlier, link to our Langchain semantic integration as well. That's the semantic caching that James talked about. Azure OpenAI Studio integration. This is another thing we announced at Ignite. Is the preview for that integration. Actually, it's now GA, isn't it? They just GA'd just like a week or two ago. But you can go and really quickly prototype RAG pattern applications using MongoDB vCore with Azure OpenAI Studio and do it without any code at all. So that's a really cool feature that these guys have built in the studio, in the portal. You can even go and deploy it as a real easy web app and share that with people as well. So we got the solution accelerator and then the chat application demo that I showed as well, and then the RAG with the Cosmos DB plus Langchain that Jasmine showed there. So, all right, one more question, I think, from Very Sticky Rice. I love that tag. How does performance scale with increasing data volume and query complexity? James, that's another good one for you, isn't it?
Yeah, so if we're talking, I think we're maybe talking about Cosmos DB for MongoDB vCore. And so there's a couple of ways, right? So like any database, when you increase the amount of data volume that you have, your queries or your vector searches can take a little bit longer. So there's a couple of things that you can do, right? One is you can change the parameters of your vector index. And two is you can actually scale up your instance, your Cosmos DB for MongoDB vCore compute. So by trying one of those two things, you can typically get more performance out of your vector search operations. Again, like the question is like, how does performance scale? It really depends on your scenario and your scale. I can tell you that, from our own internal benchmarks, we're able to configure Cosmos DB for MongoDB vCore to do vector search on millions and millions of Azure OpenAI embeddings and have incredibly high throughput, thousands of queries per second at high accuracy. So there is a right solution for you, regardless of what your scale is in Cosmos DB for MongoDB vCore.
Yeah, that's great. All right. Well, I think we've hit it all. We're through our slides. We're through our demos. We hope you had a great time joining us and talking about building intelligent applications using Azure Cosmos DB. We've got lots more coming. Come see it at Fabric Conference. That's the week of March 24th in Las Vegas. And absolutely come check us out at Build. We're going to have a ton of great announcements, a ton of great stuff to show, and even more stuff that we didn't even share here today. So come see us make news there at Build coming up towards the end of May. I think that's it. Jasmine, thanks for joining us today, and James and Gall. Thank you, everyone. This was a lot of fun. And everyone at home, we hope you enjoyed watching this.